In 7.4, our objective is to be able to find the side lengths of special right triangles. So what we're going to talk about today is that there are two types of special right triangles. There are acute angles, have special measurements, and we have shortcuts. So today's very exciting because it's all about shortcuts, how to do things faster. Well, what do I mean by that is finding side lengths of right triangles. How do we usually do that? What do we do to find the side lengths of right triangles, the side lengths that we often call A, B, and C? That's right, we use the Pythagorean theorem. So if I were to say, here's a right triangle, just looking at this first picture, use the Pythagorean theorem to find the missing side length. Well, remember what that is. C squared equals A squared plus B squared. So if these two sides are congruent, therefore I know they're both 3, and I don't know the hypotenuse, so I'm going to call that the C. I would say C squared equals 3 squared plus 3 squared. Well, C squared equals 9 plus 9 is 18, and therefore taking the square root and simplifying, breaking this down into square root of 9 times 2, C is 3 radical 2. So I could use the Pythagorean to figure out that the hypotenuse is 3 radical 2. However, today the point is I don't have to use the Pythagorean theorem every time. There are shortcuts for two special right triangles. The first of these two right triangles is the isosceles right triangle. So just to quick review, what does that mean for the triangle to be isosceles? At least two congruent sides. For it to be a right triangle, there's a 90-degree angle. I should have said a 190-degree angle. And therefore, what does that mean about the triangle? Besides that there's a right angle, there's two congruent sides. If there's a right angle, remember that the other side, the third side, the hypotenuse, has to be the longest side because the 190-degree angle is the largest angle. Well, in that same sense, across from these two congruent sides, so across from this side, is an angle that is congruent to the angle that's across from the congruent side. So if those two angles are congruent and all of these angles have to add up to 180 degrees, well, I already have one that's 90. So take away that one that's 90, we have 90 left over, divide it evenly between those two, and we get 45. So each of these acute angles are 45 degrees. So our isosceles right triangle, we call a 45, 45, 90 triangle. That's our first of the two special right triangles. So let's write down that our isosceles right triangle is called the 45, 45, 90 triangle. So what are the shortcuts for that? Well, remember when we did the Pythagorean theorem, all of these steps to find out that the hypotenuse is 3 times the square root of 2? That's a shortcut. There are two 3's. The legs are always congruent because it's an isosceles triangle. Because I have two of them, doubling what I've squared, I'm always going to have that 2 radicand left over. So I always have 3, whatever the leg was. I always have whatever the leg was and then times the square root of 2. So this is the shortcut we want to remember. If we're given a leg, like I was in that Pythagorean theorem example, so I need the hypotenuse, and we're given the leg, this is what we think to ourselves. The hypotenuse is the leg, whatever the leg number is, times the square root of 2. The hypotenuse is the leg times the square root of 2. Let's just look at a couple of examples when it's given the leg, find the hypotenuse. Find the missing side lengths for each triangle. So I see this is a 45 degrees, which means this has to be a 45 degrees. I know there's two congruent angles, so there must be two congruent sides. This is 10, so this is 10. The shortcut, the formula, says that the hypotenuse is the leg times the square root of 2. So the hypotenuse is the leg, which is 10, times the square root of 2. That's it. That's all I have to do. That's my shortcut. I could use Pythagorean theorem, but I know it's going to give me that type of answer each and every time. So there is no work to do here. How exciting is that? I know, right? Do you want to pause the video, try the next one, and come back and see how you did? So welcome back. Let's see what you did. 8 here, 8 times the square root of 2 for the hypotenuse. Pretty awesome, right? It might get a little bit tricky when the leg that we see is not just a whole number, but there's more to it. So we know, first of all, that these are congruent. So I know this is 3 square root of 2. What is my formula? I need the hypotenuse. The hypotenuse is my leg times the square root of 2. So if that's my formula, my hypotenuse is, well, the leg from the picture is 3 square root of 2. So just to make this a little bit more, here's my leg. This is the leg. Here's my leg. 3 square root of 2. The leg must get multiplied to square root of 2. So times square root of 2. Now we're not going to leave that as a final answer because we can simplify that. How do we simplify that? Multiply the radicals together. Square root of 2 times square root of 2 is just 2. If you want to think to yourself it's square root of 4, fine, but square root of 4 becomes 2. Bring down the 3 from right here. So 3 times, this was 2, 3 times 2 is 6. So my hypotenuse is 6. So it is a faster way to do it. It is a shortcut. You do need to memorize it, but sometimes you have to simplify a little bit. If you memorize it, you'll be fine. Let's look at the examples that follow, starting with number 4. In this one, I see a 45 degrees, so I know this is a 45 degree, therefore I do have the special right triangle, but this time I'm given the hypotenuse. How do I go backwards? Well, let's go back and review our formula. If the hypotenuse is leg times the square root of 2, how do we go backwards? What's the opposite of multiplying by square root of 2? That's right, dividing by square root of 2. So let's list this other scenario. I need the leg, and I'm given the hypotenuse. So needing the leg given the hypotenuse, we just do the opposite of that. So instead of multiply by square root of 2, dividing by square root of 2. Hypotenuse divided by square root of 2. Or you can think to yourself backwards, what should this have been? So looking at this one, I can say I need my leg. It's hypotenuse divided by square root of 2. Well, my hypotenuse says 12 square root of 2, right? This says 12 square root of 2 for the hypotenuse. So in place of my hypotenuse, I'm writing 12 square root of 2. I'm supposed to divide it by square root of 2. Well, look at what happens. Square root of 2, same factor, divides out of the numerator and the denominator. So I'm left with 12. So my legs are 12 and 12. Now you could have done this by thinking, well, I have square root of 2 in the hypotenuse, so I don't have it in the legs. Sure, that's fine. Lots of ways to think about it. Want to try number 5? Pause the video, come back. So let's see what we have here. 6 square root of 2, I take my hypotenuse and I divide it by square root of 2. So what's left over? Just 6. It gets a little trickier when I don't have a square root of 2 in the hypotenuse. Now, just in case you're wondering, how do I know it's the hypotenuse? Quick review. Across from the right angle is like an arrow pointing to the hypotenuse. My right angle is like an arrow pointing to the hypotenuse. My right angle is like an arrow pointing to the hypotenuse. So this is my hypotenuse. So again, my formula is take my hypotenuse, divide it by square root of 2. So my leg is this hypotenuse. So my hypotenuse says 18. I'm placing it where hypotenuse goes, and I'm dividing it by square root of 2. Now I don't just leave it like that because we know that's not simplified when a radical is in the denominator, so we fix it. Well, how do we fix it? We don't want a radical here, so if I multiply by itself, it makes it not a radical anymore. But I need to balance that by also doing it to the top. So I multiply it to the top. Let's see where we go from here. Remember that square root of 2 times square root of 2, just 2. Let's see what we have left before we get too carried away. 18 times the square root of 2 is on top. Just 2 is on the bottom. We're almost done, but I actually can do one more thing here. 2 is now outside of the radical. 18 is outside of the radical. I can divide 2 into 18. It goes in 9 times. So what's left over ultimately? 9 times the square root of 2. Now there's other ways to think about how we can find these lengths, but this is a way that'll work every time. Just make sure you memorize the properties.